Okay, hi everyone, so we're looking at solving linear equations today. So this was a half-term 2 topic, it was quite requested, and it's going to be leading on quite nicely to the next topic after this, which will be simultaneous equations. So with this, a quick starter, so the questions on the trail get more difficult, so if you don't start partway down the trail, that's fine, but what I want you to do is go through and solve all of these equations. So I'll go through and I'll put the answers. So if you want to pause the video now and then start working on them, I'll reveal the answers one at a time. Okay, so the first one, so for the first one you should have got a equals 7. So if you got that, good work. Next one along, so x is minus 4. Then we've got x is minus 7 over 2, so that's minus 3.5. And x is 0. And last one was x equals 5 over 3. So we're going to go through these in the next few slides. So if there's any you weren't sure of, you can watch the next few. If you got all of them right, feel free to skip ahead to the part of the video where I'm looking at equations with fractions. Okay, so this first one, we've got 5a plus 7 equals 42. So like when we were rearranging formulae, we need to try and get a on its own. So what we're going to start off by doing is subtracting 7 from both sides. So we start off with 5a plus 7 equals 42, we subtract 7 from both sides because we've got this plus 7, we just want the 5a, so we end up with 5a equals 35, and then to get back to a, we're going to divide by 5. So divide both sides by 5, that gives us a equals 7. Okay, question 2, a little bit trickier because we can see we've got x on both sides. So the first thing we're going to want to do is try and remove x from one of those sides. So if we've got 5x plus 3 equals 3x minus 5, if we subtract 3x from both sides, that will then get rid of the x on this side. So if we subtract 3x, we end up with just 2x on that side, because 5x minus 3x is 2x. Got the plus 3 still, and that equals minus 5. Then what we need to do, you can see at this point as well we've got rid of the 2 x's, so we've just got 1. So we're going to minus 3, because we've got this plus 3 here, we just want the x on its own. So take away 3, that gives us 2x equals minus 8. Careful on that bit not to accidentally add 3. So then lastly we need to divide by 2, and we get x equals minus 4. Okay, the third question, a little bit trickier because we've got it's a minus coefficient of x there. So we've got 1 minus 2x equals 8. So what I would probably do is add 2x to both sides. And what that will do is that'll get rid of the negative there, because we're adding 2x to the left, so we're just left with 1. And then on the right, we've got 8 plus 2x. So you can see we've now got rid of the negative coefficient of x. So then to get x on its own, we then need to minus 8. So we've got minus 7 equals 2x. So then to solve, we just divide by 2, which gives us minus 7 over 2 equals x. Okay, this next one, a bit harder again. We've got to expand out this bracket first. So we times out the bracket, so we have 6 plus 8x equals 6 minus 4x. So then it's similar difficulty to the one a couple before where we've got an x on both sides. So what we're going to do is add 4x to both sides. There's multiple different ways of doing this, by the way. You could also have taken away 8x, that would have achieved the same thing. Basically you just need to get rid of one of the x's. So we're adding 4x to both sides, so we've got 6 plus 12x equals 6. So then if we take away 6 from both sides, because we just want this 12x on its own, we end up with 12x equals 0. So 12 lots of something is 0, that tells us that that something is 0. So you could also see that by dividing by 12, because 0 divided by 12 equals 0. And last question, again a bit tough because we've got a negative and a bracket. So we're going to times out the bracket. So we've got 1 minus, so we've got 2 times 3, which is 6. And then we've got to remember we've got the minus from in front of the brackets, but then we've also got we've also got minus 2x in the bracket, so it's minus 4x. So I'm just going to replace that for a plus 4x, because minus is a plus, and that equals x. So we've got 1 minus 6 on this side, so that's just minus 5, plus 4x equals x. And now what we need to do is try and get rid of, because we've got two x's, we're going to try and get rid of one of them, so let's subtract x from both sides. Let's get rid of the one on the right. So we have minus 5 plus 3x equals 0. So then if we add 5 to both sides, that gives us 3x equals 5. And last step, we divide by 3. So I'm sure some of you are confident with them already, but if you're not, this is just a quick recap. So if you wanted to, before you started on some of the fraction ones, you could have a go. There's on the warm-up questions of the core book worksheet that I've set. There's some that are like this. So if you want to start off with them, that's great. Okay, so here's some more practice questions. So if you want to have a go at these, I'll put the answers up on the next slide. You don't have to do all of them, and you don't have to do them if you're already confident with this, but I'll reveal the answers after this. So if you do want to do any, just to check, so you can start on some of the later questions if you're feeling confident already. And here are the answers to those ones, so check that you've got those ones right before you move on. Okay, so what we're going to be looking at now is equations with fractions. So we did look at a similar thing to this when we're doing rearranging formulae, and it is a little bit trickier when we have a fraction, but the skill that we used when we're rearranging formulae is very much the same as what we're going to do here. What we're going to be doing is trying to get rid of the fraction, basically, so we're going to times by the denominator. So because we've got a denominator of 3 here, that's x divided by 3. The opposite of dividing by 3 is timesing by 3. So we can do that to both sides, and that just gives us the answer then, x equals 6. Because if we have x divided by 3, and then we times by 3, that just leaves us x. And then on the right hand side we've got 2 times 3, which is 6. Okay, so slightly trickier now, but same concept. So here we've got 2x minus 1, all divided by 3, and that equals 5. So to get rid of the denominator there, what we can do is times both sides by 3, because we're dividing the left by 3. If we times it by 3, that just gets rid of the denominator. So we've got 2x minus 1 equals, and then we've got 5 times 3, which is 15. So to get to there, we're timesing by 3 on both sides. And then all we do with this, just solve it like we normally would. So we've got add 1 to both sides, and then divide by 2. So it's similar kind of idea. When you've got a denominator, the first thing you're going to try and do is immediately get rid of that if you can. Okay, so here's a couple of extra ones. I will go through these because they are slightly different, but if you want to pause and have a go at yourself, you can do. Okay, so with this we can see we've got a denominator, but it's not on its own. So what we want to do is try and get it so it is on its own first. So to do that, we're going to add 2 to both sides first. So we end up with x over 3 equals 7. And then from there, we've got our denominator on our own. So we can now times by 3 to get rid of that denominator. So we end up with x equals 21. Okay, next one up, we've got a similar kind of idea. So if you did want to pause the video now and just check that you've understood the method of the first example, you can do. Right, so we've got this fraction, x over 4, but the problem is, at the moment, this isn't on its own, so we need to get that on its own first. So what we're going to do is we're going to add 5 to both sides. So we've got x over 4 equals x plus 5. And we can see that we've got 2 x's on this, so an x on both sides, but we can sort that out when we times it out. So if we times now by 4, to get rid of the denominator, we have x equals, and then we're timesing the whole of this side by 4. So we've times the whole left hand side, so we also need to times the whole right hand side. So what I'm going to do is write it in brackets like this to show that I've times the whole of x plus 5 by 4. So then I can expand that out, so I've got x equals, so it'll be 4x plus 20. And notice that this would be the same as if I just times both things by 4. So if I times x by 4 and times 5 by 4. As long as I times everything by 4, I get the same answer either way. I've just done it in 2 steps to make that clearer. And from now, I can start to solve. So if I take away x from both sides, that gives me 0 equals 3x plus 20. So you can see it's getting a little bit simpler. We need to minus 20 from both sides. So we end up with minus 20 equals 3x. I'll just go up here, well, there's some extra space. So minus 20 equals 3x. So just to get x, we divide by 3, so we get minus 20 over 3 equals x. So definitely quite a few more steps there, because it is a fraction one and also has 2 x's, so definitely a bit tougher. But the same kind of idea, you're trying to get rid of the denominator as quickly as you can, and then from there, you'll be able to then solve. Okay, so here's some to practice. So maybe have a go at the first couple, the last one is definitely a bit tougher. So if you want to just watch me do that one, that is fine. I think that's slightly tougher than what we need at this point. So if you want to skip over that one, that is fine. But have a go at questions 1 and 2. Okay, so question 1. So we start off, we add the 1 to both sides. So that gives us x over 4 equals 11. And from there, we can times both sides by 4 to get x equals 44. So started off adding 1, and then we times by 4. So this one, a bit tougher because we've got x plus 3 in the denominator, but the idea is the same. We're still going to try and get rid of that. So we're going to times both sides by x plus 3. So if we times both sides by x plus 3, that gives us x equals, we've got to remember to do it to both sides, so that'll be 4x plus 3. So then that would give us x equals 4x plus 12. So then let's subtract 4x from both sides, which gives us minus 3x equals 12. And then we've got this negative coefficient of x, so we can just divide by it. So we can divide by minus 3. So this isn't one we've done yet this video, but I think we did do it when we were rearranging formulae. So divide by minus 3 gives me x equals 12 over minus 3, or minus 4, because we've got a positive divided by a negative there. Okay, just shuffled that round a bit so I've got some extra space to work on this last one. So we've got x over 5 equals 1 plus, and then in 2 brackets, x minus 3. So what we're going to want to do is start off by getting rid of the denominator as quickly as we can. So we've got this x over 5. What we're going to have to do is times both sides by 5. So if I times this side by 5, that just gives me x. If I times this side by 5, I'm going to have, so 1 times 5, which is 5, plus, and then this second thing is 2 lots of x minus 3. So if I times that by 5, I'll then have 10 lots of x minus 3. So I've basically just times both parts by 5. So rather than doing it as 5 brackets and then all of this and having to expand it, I've just done it in one step. Okay, so now I can start to solve. So I've got x equals 5 plus, and you times out this, so I've got 10x minus 30. Well, that should be a plus, I'll just make that a bit neater. And then you can see now I've got two x's, so I'm going to subtract x from both sides to get rid of this x on the left. So I end up with 0 equals 5 plus 9x minus 30, because I had 10x, I've taken away x, that's just given me 9x. So I can collect up the like terms, which is 5 and minus 30. So not doing anything to the left, but 5 minus 30 is minus 25. I've still got that plus 9x. And so then I need to try and get, oh, that should be 9x. I need to try and get the 9x on its own, so I'm going to add 25 to both sides. So what that'll do is that'll leave me with 9x on the left. And last step now is I need to divide by 9, because I've got 9x, I just want x. So I'm doing 25 over 9 equals x, and it's fine that I've got a fractional answer. We can just leave it in that form. If it was a calculator paper and asked it with decimal places, you would work that out, but if not, just leave it as a fraction. Okay, so here's a few extra questions to have a go at before you make a start on the sheet. So I'll reveal the answers for these in a second. So have a go at these, check how you're getting on. I think the last couple are a bit harder than what we need. But if you can do up to question 4, that is great. I think up to question 3 is probably about standard. So 4 is good, 5 and 6 are very good. Okay, and here's the answers for the last set. So when you finish that, go ahead and have a go at the sheet. The sheets are, so the first section is a warm up, they're easier, and then after that they're all involving fractions and they do get progressively harder. So yeah, good luck with them.